Wagner Electronics has been designing moisture meters and moisture measurement systems for over 40 years. Starting in the primary forest products industry, providing large systems for lumber mills, Wagner has been involved in the measurement of moisture content in wood for many years. Well over 20 years ago, Wagner introduced its first of its line of industrial handheld moisture meters for these very sawmills. Over 15 years ago, Wagner introduced the first of its smaller line of handheld meters for use by flooring contractors, woodworkers, general contractors, and others who needed a smaller, compact unit but still had the accuracy of the well-known Wagner capacitance technology used in industrial sawmills. A number of years ago, Wagner introduced its line of digital moisture meters, the MMC MMI line, and this is one of those products. In a 10-year span, Wagner meters were twice chosen as the writer's choice in Fine Woodworking magazine as the meter that this author would use in measuring the moisture content in wood for fine woodworking applications. Wagner Electronics electromagnetic wave technology has many advantages. When it was introduced in the mid-80s, it revolutionized the way that moisture content was measured in lumber, and we've just carried that through to the present day. So let's just begin to talk about some of the advantages of Wagner's electromagnetic wave technology as opposed to the older pin-type resistance technology. There are many advantages to Wagner's electromagnetic wave technology when used to measure moisture content in lumber, opposed to using pin-type resistance meters to do the job. Let's begin to talk about some of those advantages. First of all, the Wagner technology, the electromagnetic wave technology for the moisture meters, is not, as has been said by some over the years, a surface measurement technology. It is not at all. Nothing could be further from the truth. When you're using Wagner moisture meters, you're measuring completely through the wood to get the true average moisture content of that piece of wood. Now, why is that important? There is an American Society for Testing and Materials, otherwise known as ASTM, laboratory oven dry standard for measuring the moisture content in samples of lumber to determine the true moisture content. This is the reference to which all moisture meters for wood are compared for accuracy. It's basically a calibration reference. Wagner moisture meters measure into the wood deeply and not just a surface reading, and is very closely aligned to this standard. And let me show you this for a minute. Let's take a Wagner moisture meter on a nice piece of flooring here, and I'm going to hold it up, place it on here, and you can see we're getting a reading. Now I'm going to place my hand behind the flooring where the sensor is, and you'll definitely see the moisture content go up because my hand is very wet and very dense. So you can see that. We are reading into the wood, and in the case of this flooring here, let's just look at it here, we're reading full thickness through the piece, getting the accurate average moisture content of that piece of lumber or piece of flooring in this particular case. Now, with a pin meter, unless you have insulated shafts on the pins, and you can acquire those from pin meter manufacturers, but unless you have that with a pin meter and you measure specifically at the correct depth that would give you the average moisture content of that piece of wood, you're not getting the true average MC. For example, I'm going to take a type of hammer device that actually hooks into a meter, and this is pretty typical for pin-type moisture meters. These particular pins don't have an insulated shaft at all, so you're not just reading at the tip at a specific depth, so you're not getting that actual average moisture content unless you're very, very careful. I'm going to use this right now. I'm barely at the surface. I have not penetrated that piece of wood hardly at all. So let's just look at what we're actually sensing with the two different types. First of all, we have the Wagner meter. Here's the sensor, about 1.5 inches by 2 inches long, maybe 1.5 inches by 2.5 inches area, measuring completely through the piece of lumber, getting a composite reading, that true average that we talked about. To get the same kind of result with a pin type meter, you would have to, because you're only measuring a very small area between these two pins, you would have to stab that piece of wood within that area that we're reading with the Wagner meter numerous times at different depths to approximate what you're getting easily with the Wagner electromagnetic wave technology. So earlier you were able to see some example of what happens when you use a pin meter in wood, and the fact that you can't avoid putting holes in the wood. You don't do that with Wagner technology, obviously. Again, we're reading through the material or well into it if it's thicker material, giving you a true average moisture content of what that wood is. But with a pin meter, if you're using it, and here we've got some nice flooring. I had a difficult time just getting the pins into the flooring. It's very, very hard. And this isn't even the hardest flooring that you can get. But here's a very good example. I've put a number of holes in this piece of junk lumber right here. And just to approximate the reading that you get with a Wagner meter, I had to put a number of holes in a particular area. This is a little easier to put holes in, but there are a lot of holes in this lumber. But you do not get unsightly holes with Wagner technology. It was designed for that and designed to be accurate.